Okay, today, guys, we're going to talk about solving rational equations. All we're going to be doing is finding out what x equals. And we're going to find out what x equals when fractions are involved. So there's two types of equations we're going to look at today. We're going to look at one where we can solve by cross multiplying, and then one where we have to get a common denominator. When you have this situation where you have one fraction, if I could spell correctly, if you could have one fraction equal to a fraction, you can cross multiply. Do you understand what I mean by that? Do you see how there's one fraction on the left hand side and one fraction on the right hand side? Everybody see that? Yes? Does that make sense? Okay, so then you can use cross multiplication. Every single time you guys solve an equation and it's a rational equation, meaning there's a fraction, you have to check your answer. You have to make sure the answer that you get for x, when you plug it back into the original, it does not make either denominator 0. So we're going to do that every single time. Do you guys notice here in this first example how you have a fraction on the left, fraction on the right, so we can cross multiply. That's what we're going to do. 9 times x plus 1 equals, and cross on this side, 3 times 4x plus 5. And now we just solved that basic equation. What do we do with the 9 out in front? Distribute. So you have 9x plus 9. Over here we distribute. We have 12x plus 15. And then we solve. X is on one side, numbers on the other. So it doesn't matter which way. If you guys want to move the 9 to the right and the negative or 15 to the left, that's fine. I'm going to go the opposite. I'm going to move negative 12x, and then I'm going to subtract 9. Because I personally like letters on the left-hand side. So 9 minus 12 gives me negative 3x, correct? Equals, what's 15 minus 9? 6. Now divide both sides by negative 3. And x equals what? X equals what? Negative 2. Okay, good. Now, take a second to check. Does this make either denominator 0? If I plug in negative 2 right here, is my denominator going to become 0? What's negative 2 plus 1? Negative 1, thank you. If I plug in negative 2 here, what's 4 times negative 2? Negative 8 plus 5, is that going to make it 0? No. When you plug your x back in, it should A, not make either denominator 0, and it should make your equation true. But if it does make the denominator 0, you would cross it off and say it's an extraneous solution. That one doesn't work. So let's run through a few of these. Do you guys see how this is a fraction equal to a fraction? So what can we do? Cross multiply. So 2 times 5x equals 3 times x minus 7. You can cross either way. You could do 3 times x minus 7 first and then 2 times 5x on the other side. Doesn't matter. But we're going to multiply here. So I have 10x equals 3x minus 21. Stop me if I make any mistakes, guys. So I'm going to subtract 3x from either side. I get 7x equals negative 21. And then I'm going to divide both sides by 7, and I get x equals negative 3. Now, what do I need to check for? What do we need to check for? Extraneous solutions. I need to make sure that when I plug in negative 3, that neither denominator becomes 0. So 5 times negative 3, negative 15, we're good. Negative 3 minus 7, negative 10, we're good. All right, moving along. A fraction equal to a fraction. Cross multiply. 5 times x plus 3. Excuse me. And then I have negative 4 times x minus 3. Be careful with signs here, guys. When you distribute, we have 5x plus 15 equals negative 4x plus 12. Negative times a negative is a positive. Excuse me. I'm going to move x's to the left and numbers to the right. So I'm going to add 4x here. And I'm going to subtract 15. So 4 plus 5 gives me 9x. My 15's cancel. My negative 4x's cancel. And 12 minus 15 is negative 3. Now when I divide both sides by 9, my answer is not negative 3, guys. What's negative 3 divided by 9? Negative 1/3. Perfect. So negative 1/3. Now in either case, if I plug in negative 1/3, am I going to get a 0 in my denominator? Guys, you should be able to look at that and see. What would the only thing that would give you a 0 if it was negative 3 or what? Positive 3. So no, you're fine. You're good to go here. All right, one more. Do I have a fraction equal to a fraction? Yes, so let's go ahead and cross multiply. This one's a little bit different, so watch. I have x times 2x plus 5 equals 1 times 11x plus 8. When we distribute, you have 2x squared plus 5x equals 11x plus 8, correct? This is a quadratic. How do I know by looking at this if this is a quadratic? How do you know this is a quadratic, guys? Because of x squared. Perfect. When you have a quadratic, we need to move everything to one side. So I'm going to subtract my 11x and subtract 8 from both sides. So 2x squared plus 5x minus 11x minus 8 equals 0. Now we can clean that up. Do you guys see any like terms that we can combine? What can we combine? 5x and negative 11x, thank you. So I have 2x squared, positive 5x and negative 11x is going to give me negative 6x minus 8 equals 0. So now we have to factor. When we factor, ladies and gents, what's the first thing we look to take out? GCF, perfect. Is there a GCF between the three of these? Yeah, I can take out a 2, perfect. So I have x squared minus 3x minus 4 equals 0. Now can we factor this? So I have 2. What times what will give me a negative 4 when I multiply, but a negative 3 when I add? Negative 4, positive 1. Perfect. So now you take each piece and set equal to 0. So 2 equals 0. No. X minus 4 equals 0. X plus 1 equals 0. So my two answers are x equals 4 and x equals negative 1. Do both of those work? Just look at it for a second. If I plug in positive 4, 2 times 4 is 8 plus 5, 13. Okay, fine. If I plug in positive 4 on the other side, 11 times 4 is 44 plus 8. Okay, fine. What about negative 1? 2 times negative 1 plus 5. Good. Excuse me. 11 times negative 1 plus 8. Good. Nothing becomes 0, so we're good to go here. Questions? When you have a fraction equal to a fraction, it's real easy. We can just go ahead and cross multiply. So now we're going to talk a little bit about what we did yesterday when we found our common denominator. Now the beauty about this, guys, is once you find the common denominator, I'm going to do it with this one first problem, and then you'll see how you don't have to do it every single time. Once you find the common denominator, the denominator disappears. So when I look at letter A, what is the common denominator between x, 4, and x? What are all the different pieces? What are the different things you see in the denominator? I see a 4 in one of the denominators. What else do you see? You see an x? Okay, perfect. So now we're going to look at each fraction individually, and we're going to see what it has and what it's missing. So this first fraction right here, it has the x. What is it missing? The 4. So if you multiply the bottom by 4, then you multiply the top by 4. Agreed? Okay, the second fraction has the 4. What's it missing? The x, so you multiply the bottom and the top. Perfect. The third fraction has the x. What's it missing? The 4. Multiply bottom and top by 4. Now do you guys see that this denominator is the same as this one? Everything looks the same, correct? Do you guys see that? So then your denominator disappears. You don't have to worry about it anymore because the left-hand side of your equation is equivalent to the right, so you can just disregard the denominator. All you have now is an equation. What's 5 times 4? 20. Plus, what's 7 times x? 7x. Equals, what's negative 9 times 4? Negative 36. And you solve the equation. So I'm going to subtract 20 from both sides. 7x equals, what's negative 36 minus 20? Negative 56. And then I divide both sides by 7, so x equals what? Negative 8. And what's the one thing I have to do? I have to check to see if what? I have to check to see if I plug in negative 8, if my denominator becomes what? 0. Does it? No. If I plug in negative 8 for x, it's not a 0, so you're good to go. So once you get everything to have the same denominator, you could just disregard the denominator. You don't have to look at it anymore. For letter B, what number is under 1? 1. Okay, so I'm going to write a little side work over here. What's my common denominator between 1, x minus 5, and x? What are all the different pieces you have? What are all the different pieces you have? 1, x, and x minus 5. Perfect. Remember that negative 5 is stuck with the x. So now you look at each fraction individually. See what one has, what it doesn't. Look at the first fraction. What does 1? What does the 1 have, and what is it missing in the denominator? What's it missing? X and x minus 5. So what you do to the bottom, you do to the top. So x times x minus 5, all right? Look at your second fraction, the 8. What is it missing? It has the x minus 5. It's just missing the x, so top and bottom. And then look at 3. What does it have? What is it missing? It's missing the x minus 5. Good. If you guys write it out, you can actually see, oh, look, now they all have this, everything has the same thing. So now that I have made all the denominators the same, what can I do to that denominator? I can cross it off. I don't have to look at it anymore. So now I'm just left with, can I distribute this here, guys? I have x squared minus 5x minus 8x equals, distribute here, 3x minus 15. And it's just a simple equation. Let's clean up. I have x squared minus 13x. And then if I move these two over here, it becomes negative 3x plus 15. Change the signs. Why'd I put a parenthesis? So I have x squared minus 13, 14, 15, 16. Yeah, 16x plus 15 equals 0. Can you factor that? What times what gives you a positive 15 when you multiply, but a negative 16 when you add? What are the factors of 15? 1 and 15 or 3 and 5? Which one will give you a positive 15 when you multiply, but a negative 16 when you add? Negative 1 and negative 15. So when we set this equal to 0, you get x equals 1 and x equals 15. What do I need to do with those two numbers? I need to plug it into the denominator and make sure it does not become what? 0. So if I plug in 1, 1 minus 5, not 0. If I plug in 15, 15 minus 5, not 0. Good to go. Everybody okay? Oh, there's no more in here? Okay. Let's go to the next ones. Is this the last examples? But I mean for, geez. Okay. All right, here we go. Let's get a little side work over here. What's going to be a common denominator between x and 5 and x? 5x. Okay, perfect. You guys are getting better at this. So look at each fraction individually. I keep saying the same thing over and over and over again. I know that. My first fraction has the x in the denominator. What's it missing? The 5. Perfect. So you multiply the bottom and top by 5. The second fraction has the 5. What's it missing? The x. Perfect. Top and bottom. The last fraction has the x. What's it missing? Perfect, guys. So now that my denominator, look, each denominator has 5x, 5x, 5x. What can I do to it? Cross it off. So I say 15 times 5 is 75 plus 4x equals 35. Subtract 75 from both sides. 4x equals what? Negative 40. What's x equal? Negative 10. If I plug in negative 10 here or here, does my denominator become 0? No. All right, same thing. Can I just cross multiply here? Do I have one fraction on one side equals one fraction on the other side? No. Guys, if you need to, put this in parentheses so you see that x plus 1 is stuck together. So do a little side work here. What are the different pieces of the denominators that you see? I see a 2x and a what? X plus 1. Perfect. So let's look at each fraction independently. This first fraction has the x plus 1. It's missing what? The 2x. So multiply the bottom and the top by 2x. The second fraction has the 2x. What's it missing? X plus 1. Good. And then the last fraction has the 2x. What's it missing? The x plus 1. Now that the denominators are the same, what can I do? Cross it off. Now look, guys, I'm going to write this out so you see it. This says 3x times 2x minus 5 times x plus 1 equals 3 times x plus 1. Do you see that minus sign in front of the 5? Remember, that's going to distribute to everything behind. So when I have 3 times 2, I get 6x squared. What's negative 5 times x? Negative 5x. What's negative 5 times 1? Negative 5. And then we distribute here. So I have 3x plus 3. I have a quadratic, so I need to move everything where? To one side. So I'm going to subtract 3x and 3 from both sides. So minus 3x minus 3. So I have 6x squared minus 8x minus 8 equals 0. Common denominator? 2. Okay, take out a 2. I have 3x squared minus 4x minus 4 equals 0. You guys agree? All right, well, this is a little different factoring. Let's see if we can remember how to do this. Let's see if this does factor. So I take a times c. 3 times negative 4 is negative 12. Do I have factors of negative 12? That'll multiply to give me a negative 12, but add to give me a negative 4. Positive, yep, negative 6, positive 2. Good job, bud. Now, guys, this is a little different, remember, because your a term, the number in front of x squared, is not 1. So what do I have to do with this a term? I have to divide it. Good. Both factors, I have to divide. See if it divides out. If it does, great. If not, it becomes coefficient. So I have 2. What's 6 divided by 3? What's 6 divided by 3? 2. Good. Does 2 divide by 3 pretty? Nope, so this is just going to come out in front here. I have 3x plus 2 equals 0. Now I set each piece equal to what? Yep. Is 2 ever going to equal 0? No. Here I have x equals 2, and here I have x equals negative 2 over 3. Move 2 to the other side, becomes negative. Divide by 3. And what's the thing I have to remember to do? I got to check to make sure my denominator does not become 0. That's real easy to do, guys. If you look at that, 2 plus 1, not a problem. 2 times 2, not a problem. 2 works. Negative 2/3 plus 1. You may not know right off the top of your head, oh, I'm not sure I got to get a common denominator, but you should be able to understand, oh, it doesn't make my denominator 0. So we're good to go here. The biggest thing is this first step of finding a common denominator, and then it's just algebra 1 from there. All right, let's look at this last one, then we'll do a couple more examples, and then we're going to be done. If you guys notice here, I have x plus 1, put it in parentheses. Can I factor x squared minus 1? Yes, x squared, x plus 1, x minus 1 is the difference of squares. And then what's underneath this 3? A 1. So remember, we're trying to find what the common denominator would be. What would the common denominator be between x plus 1, x minus 1, and 1? X plus 1, x minus 1? All right, so what does the first fraction have? X plus 1, what's it missing? The x minus 1. So if I multiply bottom and top by x minus 1, my second fraction has both of them, right? So we're good to go. What does the third fraction need? X plus 1 and x minus 1. It needs them both. And now that we have a common denominator, what do we do with the bottom? We cross it off. So I'm going to write out the whole thing so you can see it. You have 4x plus 1. This is x minus 1. Equals 12 plus 3 times x plus 1, x minus 1. And this is just a big factoring problem. That's it. You're going to FOIL together and then factor if you can. So let's FOIL the first here. What's 4x times x? 4x squared. What's 4x times negative 1? Minus 4x. 1 times x is x. 1 times negative 1 is minus 1. Then on the other side, I have 12 plus. We can leave that 3 here. What's x times x? X squared. What's x times negative 1? Minus x. 1 times x plus x. 1 and negative 1, negative 1. You guys don't have to do everything in one step. It's no big deal. You can take a few steps. Let's go ahead and clean this up. What can I clean up here? This is going to become 4x squared minus 3x minus 1. You guys agree? And then over here, I'm going to keep that 12 here. What's going to happen with my positive x and negative x? They're going to cancel. So you can now just say, okay, I have plus 3x squared minus 3. This is an obvious quadratic because you have an x squared. So move x, everything to one side. So I'm going to subtract 3x squared. Subtract 3x squared. Can I combine these two? What's 12 minus 3? 12 minus 3 is 9. So this is really positive 9. So let's move the 9 to the other side. Well, let's see what we get here. 4x squared minus 3x squared is x squared. Minus 3x minus 10 equals 0. It's another factoring problem. What times what will give me a negative 10 when I multiply, but a negative 3 when I add? Perfect. X minus 5, x plus 2. So my two answers here become x equals 5 and x equals negative 2. Do either of those values make my denominator 0 if I plug it back in? Nope. So we're good. If you are not super great at factoring, guys, Algebra 2 is really, really, really heavy in factoring. You cannot just go, oh, I'm not good at factoring. The first part, oh no. We have to get good at it. We will get good at it. All right, we're almost done, I promise. Where do you think I start here? What should I do? I love it. Good. What could I rewrite this as? Plus 3 minus 3? Perfect. So guys, what is our common denominator going to be between all of these? X minus 3 and plus 3. Perfect. So let's see what each fraction has and what it's missing. My first fraction with my numerator of 6 has the x minus 3. What is it missing? X plus 3, so you top and bottom. My second fraction has both of them, doesn't it? So you're good to go. What about my third fraction? Missing the x minus 3. Now that my denominator is the same, I can disregard. I don't have to worry about it right now. Now I'm going to write out what I have in the numerator. 6 times x plus 3 equals 8x squared minus 4x times x minus 3. Here comes algebra. Let's distribute. So 6x plus 18 equals 8x squared minus 4x squared plus 12x. You guys agree? Okay. So we can combine these two and make it 4x squared. So let's move everything to one side. Everything to one side. In this case, I know every single time I've moved everything to the left. In this case, I'm going to move everything to the right. How come?
Because it's like there's more numbers.
Okay, there's more numbers on the right. What's another reason why? Look at your 4x squared. Is it positive? If I move it to the left, what's it going to become? Negative. We don't want to deal with that. We don't want to have to factor negative. So I'm just going to go ahead and move these over here. Minus 6x minus 18. Minus 6x minus 18. Do you have to do that? Absolutely not. If you don't mind dealing with negatives, more power to you. I'm just not a fan. So I'm left with 4x squared my plus 6x, right? Minus 18 equals 0. If we factor this, what could I take out of all three of these? 2. So 2x squared plus 3x minus what? 9. So A times C. What times what will give me a negative 18 when I multiply, but a positive 3 when I add? Perfect. Plus 6 minus 3. And my A term is not 1, so what do I do with it? Divide. Awesome. For the 3 of you that are still here with me, I appreciate it. So I have 2x plus 3 and 2x minus 3. If you guys do not understand how I factor when A is not 1, you can ask me as soon as I'm done here. We can go over more problems. You can come see me before or after school, or you can do it the way that you'd like. But you have to figure out a way of factoring that works for you, as long as mathematically it makes sense. So I have 2 equals 0, x plus 3 equals 0, 2x minus 3 equals 0. Does 2 ever equal 0? No. Here I have x equals negative 3, and here I have x equals, if I move negative 3 over, it becomes positive, and then I divide by 2, so I have 3 over 2. Check your denominators. If I plug in negative 3, guys, negative 3 minus 3, we're good. What happens when I plug in negative 3 here? It becomes 0. So what did we just figure out about x equals negative 3? Is that a valid solution? No, cross it out. It does not work. If you leave that on your quiz and say, oh, I got 2 solutions, no, you've got to make sure your denominator does not become 0. This is what's called extraneous. It's extra, like some of you guys sometimes, like my girls. So I really only have one solution here. I have one valid solution, one that makes the equation true. Do you guys see the importance of checking? You have to. All right, how many more of these we got? All right, we can do it. We can do it. What am I going to do? Factor. Perfect. This is plus 2 minus 2, correct? All right, so what's our common denominator going to be, guys? X plus 2 and x minus 2. All right, so first fraction is missing the x plus 2, correct? What you do to the bottom, you do to the top. My second fraction is missing the x minus 2. What you do to the bottom, you do to the top. And my third fraction has it all. But now that we have everything the same denominator, we can disregard it. So I have 9 times x plus 2 plus 6x times x minus 2 equals 9x squared. Distribute, so 9x plus 18 plus distribute 6x squared minus, 12x equals 9x squared. Combine any like terms you can, so 9x and negative 12x. So 6x squared minus 3x plus 18 equals 9x squared. Now, again, you guys can move the 9x squared over if you want to. But then your x squareds become negative, so you'd have to factor out a negative. I'm just going to move everything to the right-hand side. Actually, you know what? Let me do it so you guys can see it. If I subtract 9x squared here, do you guys see how I have negative 3x squared minus 3x plus 18 equals 0? What am I going to factor out of all 3 of those? What kind of a 3? Negative. If you moved it to the other side, you would have factored out a positive 3. Since we moved it to the left and your x squared was negative, you need to factor out that negative. So this becomes x squared plus x, what? Minus 6 equals 0. You've got to, if your x squared leaves with a negative, factor it out. So now, easy peasy, lemon squeezy. What times what's going to give me a negative 6 when I multiply, but a positive 1 when I add? Six is 1 and 6, 3 and 2. Which one? 3 and 2. Plus 3 minus 2. Set each piece equal to 0. Is negative 3 equals 0? Never. X plus 3 equals 0. X minus 2 equals 0. So you come out with the two values of x equals negative 3 and x equals positive 2. Check to see. Will both of those work? Which one doesn't? Why? Because if I plug a 2 in here, what happens to my denominator? It becomes 0. That's no bueno. So I only have one valid real solution. X equals 2 is an extraneous solution. It does not work. Last one, and then tomorrow I might talk to you guys for like 6 minutes. It'll be quick, promise. First thing I'm going to do is factor. Plus 1 minus 1, right? So what's my common denominator going to be between all three of these things? X plus 1 and? Perfect. We've done about 15 of these. You guys are you're hanging on. You're doing a great job. So the first fraction has the x minus 1. It's missing the x plus 1. Good. My second fraction's missing everything, huh? So it's missing x plus 1 and x minus 1. And then my last fraction has it all. So go ahead. I'm going to rewrite. I think this one step here of rewriting what you have is really important so you don't miss that negative sign. You have 7 times x plus 1 minus 5 times x plus 1 x minus 1 equals 6. That minus sign is a big deal because it could really affect your problem if you miss it, if you change it to a plus. So when I distribute, I have 7x plus 7. When I factor or FOIL this together, do you guys agree this becomes x squared minus 1? You guys okay with that? So when I distribute, I have negative 5 times x squared is minus 5x squared. Negative 5 and a negative 1 becomes positive 5 equals 6. That negative in the middle there is super duper important. I'm going to go ahead and move the 6 over and combine like terms. So 7 plus 5 is 12, and 12 minus 6 is... Did I do too much in one step? Okay, oh, I'm sorry. Go ahead. God bless you. Let's combine like terms. So I have negative 5x squared plus 7x. What's 7 plus 5? 12, good. Equals 6. Now I'm going to move that 6 over. When I move that 6 over, I'm going to subtract 6 from both sides, yeah? Hang on. We're almost done, we're almost done, we're almost done. So I have negative 5x squared plus 7x minus what? Or plus 6, yeah? Equals 0. Can I take out a GCF? Is there any GCF here? Negative 1. Good. Very good. There's no number other than negative 1 they have in common, but we've got to take that negative 1 out because we don't like to factor with a negative. So I have 5x squared minus 7x minus 6 equals 0. 5 times negative 6. My factors of negative 30. Are there factors of negative 30 that'll multiply to give me negative 30 but add to give me 7? Or negative 7? Let's think about 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which ones? The 10 and the 3. Perfect. I'm going to have a negative 10 and a positive 3 because I want a negative 7 when I add. Awesome. And then one step, guys. What's one last thing I have to do before I pat myself on the back and say, I'm pumped, I'm done? Not yet. Is my A term 1? What do I have to do with that 5? I have to divide each factor by 5 because my A is not 1. So I have negative 1, x minus 2, and then 5x plus 3, all equals 0. And now we can set them equal to 0. Is negative 1 ever going to equal 0? No. So I have x equals 2. And then here, guys, if I move the 3 over, it becomes negative and divide by 5. So I have negative 3/5. Are both of those valid solutions? 2 minus 1, we're good. 2 squared minus 1, we're good. Negative 3/5. If I plug in negative 3/5 for either x, is it going to become 0? No. So we're good to go. So, guys, when you get 2 answers, moral of the story, should you just automatically assume one of them is not going to work? No. Is there a possibility that one of them won't work? Yes. Okay, thank you. Sorry.